If you run a manufacturing company that builds configurable machinery or equipment, then I need you to hear this. The biggest source of waste in your operation is probably not where you think it is. It's not on the shop floor. It's not in production planning. It starts in the quoting process, and it's eating your factory capacity from the inside out. In this video, we're going to cover the errors that we keep finding in every manufacturing company we speak to, why they're so expensive, the root cause of those errors, why it's getting worse, and what actually fixes it. I'm Patrick. I am the founder of Anora, and we build quoting and operation systems for manufacturing companies, specifically companies that build machinery and equipment like cranes, conveyors, industrial fans, and packaging equipment. I'm a mechanical engineer by background, and I spent years inside manufacturing companies using AI, automation, and data to find opportunities to make more money for manufacturing companies, reduce waste, increase profitability, increase capacity. And over the past 2 years, I've had over 200 conversations with CEOs, VPs, sales leaders, engineers, and people on the factory floor at manufacturing companies ranging from 20 million up to $300 million a year in revenue. And I spent all of that time trying to find the real cause of why they weren't able to increase their capacity. In this video, I'm going to go through exactly what we uncovered in those conversations and the solutions that we've used to fix these problems and increase the capacity of these companies. The types of errors that we consistently see at the quoting stage are incompatible configuration, so people selecting or salespeople selecting options that do not go with each other. For example, sometimes you might have a backplate and you can't have two items attached to the same part of the machine because there's no space for them. So incompatible configurations can sometimes slip through the quoting process into engineering, and sometimes they can even slip through to the factory. And when that happens, that causes all sorts of errors that you do not want to have to deal with, including calling back your customers and telling them that you have to re-quote them on something. The second piece being completely unbuildable configurations, so things that are literally not manufacturable. And this might be shapes and sizes of parts that you physically cannot build with the machine shop that you've got in-house, or things that literally cannot be joined together. And I see this all the time. Oftentimes, these unbuildable configurations are usually caught by engineering departments. But if you have these unbuildable configurations that are consistently popping up, it means that your engineering team is wasting a ton of time that could be used to continue to develop your products or for them to support other departments in the company. We also see unnecessary customization where a standard machine would have done the job that the customer was looking for, but the custom configuration was quoted instead because the sales team thought that it would have higher margins, or the sales team thought that this was potentially a standard machine because there was no standard configuration or configuration list being given to the sales team. We sometimes see an example where the wrong options were added to the machine. So for example, the requirements for the particular customer weren't extracted correctly, or they were extracted, but they weren't taken note of, or the notes were written in a way that was not easy for someone else to understand. And this ends up with the customer getting something delivered to them that doesn't actually solve their problem. And this is probably the most costly situation that happens for manufacturers, because if your machine ends up all the way in the other company's factory, that costs you a lot of money. And I'll show you a little bit of an example in a couple seconds about why that costs you so much. Finally, just pricing errors. We often see custom machines quoted at standard prices. We often see custom machines quoted with standard lead times. And both of these are simple errors that can cost you a lot of money, especially if the company that you're selling it to imposes some sort of late penalty, or if they're not willing to pay that additional cost that you end up asking them to pay when you realize that you've quoted them a custom machine and you're charging them a standard price. Every one of these errors consumes capacity that could be producing something that a customer actually wants and is willing to pay for. And the real cost is not just the rework or the additional time that your team has to spend, or potentially the cost that you have suffered by maybe charging a lower price for something you could have charged more for, but it's really the opportunity cost of what you could have been building instead in that time where you were reworking or renegotiating something with one of your customers. But why are these errors so expensive? And what is the true cost of these errors when they do happen? There was a great study that was done back in the 90s, but Basically, what they found was that 70% of product defects originate during the planning or design phase and not on the production floor. And the cost of those errors is shown here on screen, where if something gets caught in the quoting process, you do have a little bit of a cost there. It depends on the specific amount of time that error potentially costs you. But a revised quote is usually just a quick change. It's usually just a quick conversation, and you can get back to work very quickly on whatever it is that you were quoting. Next, if engineering catches an error here, you're gonna have about a 10x cost versus when it was caught in the quoting process, because you're gonna have to go back to the customer, because you're gonna have to now renegotiate. After you've already signed a contract, you're already gonna have to do some redesign. You're gonna have to do another review process of that order. So you're now taking time from valuable engineers, you're taking time from sales engineers, you're taking time from the customer, and likely the senior management is gonna get involved in a lot of these sorts of conversations, just to make sure that there's no ongoing dispute between the two companies, especially if they often work together quite closely. Then you've got things that happen in the production side of things. Let's say, for example, a machine slips through engineering, it's an unbuildable configuration, and the machine is now sitting on the floor. If that machine is sitting on the floor and a person on the technician side starts trying to fit the machine with a couple of parts, realizes that those parts now overlap and that they can't both be put onto the machine. Now you are sitting in a situation where you could have a machine that's taking up a lot of valuable floor space, and you're going to have some form of scrap that's going to happen. You're maybe going to have to go and negotiate that again with the customer to see if they're willing to reduce or remove one of these custom options that they paid for, which likely causes some sort of schedule disruption. It likely costs some overtime for your team to have to do more work on this machine than was initially expected. And you've got idle machines, idle floor space, and all of this is costing you money every single day that machine is not being worked on. When you've got these custom machines that are slipping through and that are ending up on the factory floor, and sometimes it's not understood that it is a custom machine, there might be a custom part that needs to be ordered, and maybe that got caught in engineering and they did order that custom part. But maybe that machine is already now sitting on your floor in the manufacturing plant, and you're going to have to wait 2 or 3 weeks for that part to arrive into the factory. So you've now got a machine sitting on the floor. Maybe it's like a $200,000 machine, and it's sitting on the floor waiting for a $50 part to show up. I've seen this happen in every manufacturing company that I've talked to at least once, and I'm sure that it happens a whole lot more than I see it. And again, this is stopping your overall capacity from expanding, because it's meaning that you've got this idle floor space, it's meaning you've got idle machines, and you've often got idle staff that you're paying that aren't adding value because they're waiting for information or they're waiting for parts to arrive before they can finish off that machine. And finally, the worst of all is when a machine ends up in your customer's plant, that's sitting on the floor, and somebody tries to install it, or it gets installed and somebody realizes that there is an issue with this machine. Maybe it's like what we said earlier, and it's that the customer's specifications were not captured correctly. That is one of the worst cases of scenarios that could happen here. Maybe you've got a situation where the size that was quoted, or the size of the specification of the machine, doesn't fit the position that it's supposed to be in the factory. They may have had a specific floor space that they were expecting to put that machine in, or that air handling unit in, or whatever it might be, and now it doesn't fit there. So they're either going to have to go and rework the flow of their factory or the positioning of that machine in their factory. So you're going to have teams of people trying to figure out what the problem and the solution is here. Your service department's going to get involved. You're probably going to have to go back to engineering. You might have some warranty claims. You might potentially even lose some customers if they're really, really frustrated with what's happened. I'm sure it's very frustrating for anyone when their requirements are not captured and there's a machine sitting on the floor that they've paid thousands or hundreds of thousands of dollars for, and it doesn't suit the purpose that they bought it for. A lot of these examples that I'm giving, they probably don't happen every day, but they do often happen in manufacturing companies. And as you can see, like, the majority of these errors are not necessarily things that have happened on the factory floor that is anyone's fault in the factory. It's usually that there was something that happened further upstream in engineering, in quoting, in purchasing, in scheduling, or as I said, in that quoting process at the initial stage. And look, it's really easy to blame people in this process. It's just not that. It's not that you've got bad salespeople. It's not that you've got bad engineers. It's not that you've got a lack of discipline or training. The problem is structural, and it's imposed by the systems and the software that your team is using. So across the 200 companies that I've talked to, the pattern is always the same. There is products that are defined, but they're defined in spreadsheets, they're defined in people's heads, and the sales team doesn't have a specific system that they can go to where they can see all of the product families, every option, every valid combination, every engineering constraint, every pricing rule, and somewhere where all of that is documented, enforced, and that the invalid configurations can't even be quoted, or whenever an invalid configuration is selected, that it comes up with a notice and tells the salesperson why that probably isn't a good idea for them to quote that, or flags it as a custom configuration, lets them know that there will be a significant cost increase, there'll be a lead time increase, and that allows them to talk to the customer and try to get the customer to maybe choose something else, because really what the customer wants is to get a machine that works on their factory floor in the shortest amount of time possible and for the best price. And if you're selling a custom machine that's going to cost more and it's going to take longer to build, unless there's a really, really strong reason for them to need that customization, the majority of the time, they just want the machine faster and cheaper. So they'll take the standard configuration if they have real reason to. So what does it usually look like in a manufacturing company? Well, you've got some information in an ERP system, some information in an Excel spreadsheet that was built, years ago by someone who maybe doesn't even work at the company anymore. And a lot of the real critical information is living in people's heads. And it's often a person that's been at the company, maybe they used to work in engineering and now they work as a salesperson, or they work as an applications engineer. And they just remember that in 2016, they quoted something and it reached the factory and there was an error, and now they know not to quote that thing again. But it's not written down anywhere. There's no record of it, unless you went really digging through kind of change order requests from back in the day that might be in your ERP system, or maybe they're just in your email address or your email inbox, and maybe they're in a CRM somewhere. But it's not easy for the salesperson, especially a new salesperson, to find this information. So it has to be stored in a system that makes it easy for them. What I often see happen is that between salespeople and engineering, you always end up in this negotiation process where sales is asking engineering, is it possible for us to do this? Can you check if this is possible? And each of those loops adds days, it adds opportunity for errors, and it really just slows down the whole sales process, which means that your sales cycles expand. And there is an old adage in sales that time kills all deals. So if you are not able to get back to your potential customer within a day or within a couple of days around what it is that they asked for a quote for, the chances are they're going to find someone who can. And that person might be overseas. I know that a lot of the Chinese companies are able to provide quotes within 24 hours. And a lot of manufacturers just don't have the systems in place to be able to do that. And this gets worse when you're talking about configurations of really complex products. You've got this amount of revisions that often happen where you're going back and forth with the customer and there's continuous changes to the quotes. Again, increasing the likelihood that you're going to have some sort of errors coming through and slipping through in the quote. So the moral of the story here is that if you're quoting out of Excel and you're then entering that information into an ERP system, you're generally going to be blind to the configuration complexities of the machines that you're building. And that is not the process that you want to be running in 2026 when it is possible to solve these problems. I said earlier that this is going to get worse. And what did I mean when I said that? Well, most manufacturers have people that have been around in their business for 20, 30, 40 years. And oftentimes they've started in engineering and maybe they started in manufacturing and they've moved across the company and they've now ended up as applications engineers or salespeople. And a lot of the time, these people are able to catch a lot of these errors because they remember seeing similar patterns or similar issues in previous quotes that they've done over the years. Well, the majority of these people are going to retire over the next 3 to 5 years, or maybe 5 to 10 years. But the stats are saying that over 25% of the manufacturing workforce is 55 or older. So you're looking at about 4 million people are going to retire. But that means that we're going to need about 3.8 million new employees in manufacturing companies over the next 5 to 10 years. And we're going to be losing a ton of experience from these sales departments and from these application engineering departments. And if we lose a lot of this knowledge that lives in these people's heads, well, we maybe won't catch as many of these quoting errors so early on, and things like this could potentially get a whole lot worse. So the quoting errors are eating your capacity. The cost cascades even more at every stage. The root cause is a structural problem, and the people who compensate for it are retiring. So that's the problem, but there is a solution. This can be fixed, but it has to happen at the point of origin, which is the quoting stage. You're not going to solve this downstream with better engineers or putting robots on the factory floor. You're not going to catch this with more inspections. You need a product-based quoting system that has every option, every valid combination of those options, every constraint, every pricing rule defined and enforced by a software system that highlights when these things are not happening. This means that invalid configurations just cannot be quoted. But what does the solution even look like? Well, this would be a visual system like a web app, not an Excel sheet where your team enters data blindly into cells without understanding the core structure of how that system is built. This system would show what your salespeople are configuring, and it would show whether it's buildable, and it would also show the price in real time, including also being able to see the lead times. The idea here is this would prevent errors before they can enter the engineering department and before they slip through downstream. It also means you don't have to have every single quote checked by engineering because the rules are defined up front, which means that you can have like 20 to 40% of your engineering capacity completely freed up just by fixing some problems in the quoting process. Downstream of that, your production team gets more clean orders, rework starts to drop, your customers get faster, more accurate quotes, which often means that they can get their configuration shipped faster, which means that they're likely open to paying more, which means that your margins can increase. It also means you can onboard new salespeople faster. It means that you can have a system that almost teaches your salespeople what is buildable, so you don't have this like 3 to 5 year ramp of a salesperson. I actually had a company before where the leader of the sales team told me that after 1 year, that's when a salesperson just becomes dangerous enough to cause them problems because they have a little bit of an understanding of the product, but they don't have enough of an understanding of the products to know when they're making a mistake. So is there a name for this type of system that I talked about? Well, yes, there are traditional CPQ platforms that have been around for a long time. These systems were built for enterprises. They're kind of 6-figure to 7-figure implementations. You're talking like 12 to 24-month timelines in some cases. And it means that you've got consultants coming in and spending a ton of time with your team, which means that for most mid-market manufacturers, this is too expensive, or potentially they tried one and it costs a lot of money and maybe it didn't work for them fully and they ended up going back to Excel. But what's changed? Like, why is this now possible? Well, you might have seen some people talking about things like Claude Code. You might have heard people talking about things like OpenClaw and other AI systems that can be used to write software. Well, these systems have created a massive unlock for customizing software and building custom software around core data that you know to be true. And this means that you can fully customize software around your products, around your rules and your processes. So you don't have to try to jam your product and your rules into somebody else's predefined system, like trying to use like a Tacton CPQ or a Salesforce CPQ or a product like that, where those systems are not really built around how your products actually work. They often want you to change your process. They want you to change your products in order for you to fit into their system. Well, you don't have to do that anymore. You can build a fully custom configure price quote system yourself. And I actually have a video on the channel if you want to go and watch a video of this. That video was done quite a while ago. I will link it there, but I will be having an updated video showing CPQ systems, showing RFQ systems, and how you can build your own systems for your manufacturing company. Things in AI are moving faster than even someone who is working in the industry 24/7 can actually keep up with. So I'm sure that it's really hard, especially if you're running a manufacturing company, to try to keep up with the technology. So I'm going to keep making videos like this, letting you know of what is possible with AI, and other videos will be way more focused on the specific use cases of like how you can build things with AI, how you could look at different systems that are buildable, and giving you like real examples and showing you how these systems are built. So the main takeaway I want you to have from this video is that if you can fix your quoting process and you can catch errors before they enter downstream systems, you're not just reducing the rework that happens in the factory, you're unlocking real capacity that can help you to scale your business. We've seen companies add 20 to 50% of their factory capacity just by making small changes continuously over time to their quoting process and to the processes that happen before items reach their factory. Things like production scheduling, things like procurement to make sure that things are arriving on time and that machines aren't going on the floor until they're ready, until all of the parts have arrived. If you want a record of everything that I talked about in this video, I have created a little walkthrough here in this file. I'll share this in a link in the description down below. Feel free to share this around with people at your company or other people that you know that are interested in manufacturing. It includes a lot of the information that I talked about in this video. And if you want, you can also just share this video with them. If you found something helpful from this video, please drop a like, please subscribe. It'll help other people in the manufacturing space see more of these videos, and it'll make sure that these videos do pop up in your feed. If you think I missed something in this analysis, if you think that I maybe got something wrong, also let me know in the comments down below. Always looking to learn more about this from other people in the manufacturing space. I'm just sharing what I've learned over the past couple of years from being in this process with tons of manufacturers. Hoping you got some value from this video. If you did, please let me know in the comments down below, and I will see you in the next one. Cheers.